Hey guys, welcome to the Chapter 4 presentation for our Python programming course. Like last time, we have an agenda presentation. I'm going to go over all the key terms, but I'm going to have a lot of content on the screens. In this presentation specifically, a lot of the information is related, so a lot of it is key terms, so I'll be saying a lot of things out loud, but if you ever need to pause, feel free and go back and look at whatever you need, especially the visuals that I provide. Introduction to branching, which is a very important concept. Basically, branching in programming is a program that allows you to execute different code paths based on specific conditions that you provide. You have things that are just a single path, and you also have things that are if branches, if else branches, or if else branches, or nested branches. Basically, an if branch is saying that it executes code only if a particular condition is true. An if-else branch executes one block of code if the first condition is true, otherwise it runs another block of code. And an if-else, if-elif nested branch allows multiple conditions to be checked and executes the first matching condition. An example of branching can be seen here, where you have the starting point of the program, where you define variables and different inputs. Then it's given to your first if statement, which if it's true, it prints a particular situation. If it is false, it goes into the elif branch, which if that one is true, then it prints this situation. If that one is also false, it feeds it to the second elif branch. If that's true, it prints action 3. If that is false, it goes to the else branch, which prints whatever was given after that point, in which the code is done. Boolean logic and operators is also another important slide. A Boolean type represents a value of either true or false and is used in conditional expressions. Things like an equality operator, inequality operator, or relational operators, as well as logical operators, are used to compare or check values between each other. A briefing of comparison or checking operators is shown here, where these are all very important things to keep in mind, as in your if-else branches, you'll be using a lot of these concepts to compare different things and provide different conditions for your programs. Breaking down some concepts of logical operators is shown here for and, or, and not. It also provides the functionality and an example for them, so feel free to pause here if you'd like some visuals. Another emphasized concept in this chapter was detecting range and using operator chaining. For operator chaining, it's saying that there's a concise way to write comparisons. Implicitly, which is the concise way, is putting it all in one line. Example saying that 5 is less than x is less than 10. Instead of explicitly, where you show separate conditions, saying x is greater than 5 and x is less than 10. Both things mean the same thing, but implicitly, concisely showing it is more efficient. There is also applications of this in finding ranges of programs using if-else statements, logical operators, implicitly, explicitly, and other ways to check if a value falls within a certain range. An example of this is given in the Xilabs activity 4.18.1 for the program Leap Year. It's basically saying that we want to find what years that are given in an input are leap years, and they must meet two conditions. The year must be divisible by 4, and the year must be a century year. Or, in other words, the year must be evenly divisible by 400. Some examples are given if you'd like to pause and look at what was provided. This is the example I provided for this particular program, in which I produced two separate if statements. The first one providing that input year modulus 4 is equal to 0 and input year modulus 100 does not equal 0. or input year modulus 400 equals 0. If the first condition or the second condition is true, then we can say that is leap year is true. The second branch is saying that if is leap year is true, then we print that statement given. Else, if it is not true, or in this case, false, then we print the final statement. There are also concepts of more complex branching. Multiple distinct if statements, as shown prior to this, is using separate if statements to account for independent conditions. Membership operators, in or not in, check if a value exists within a sequence, and identity operators, is and is not, check if two variables refer to the same object in memory. Lastly, some key remarks regarding code structure and conditional expressions. We've mentioned code blocks, so I won't talk too much about that now, but importance of indentation is very prevalent when programming in Python, because Python uses indentation to define code structure instead of using something like braces. Good practice for line length is also something to bear in mind when programming, as it's always good practice to keep under 80 characters in a line, though occasionally 120 is sometimes acceptable for special cases. And conditional expressions are those that equate to either true or false and are often used in if statements. Thank you for your time. Have a good one. Good luck.